Hey, all, we're working for a solution on a challenge, functions for math on variable inputs. We're told to write a function called Euclidean distance or Euc distance that'll calculate the Euclidean distance between 2 points. We're calling the first point x1 and y1 as its coordinates. Second point has coordinates x2 and y2. And we're going to say this function takes 4 arguments representing the x and y coordinate for each of the 2 points. The function will return the Euclidean distance between those 2 points. We can find the function here on Wikipedia, right? We have the sum of the difference on the first axis. We're saying q1 minus p1 in our case. This is x1 minus x2. And we also have a second axis here. In our case, it's the y-axis, so we'd call this y1 minus y2. We square each of those differences and add them together, take their square root, and we are given the Euclidean distance. So we go back in here to actually code this out. Of course, the first thing that we want to do is to define the function name and its parameters. We were told we were given a point. The first point is got coordinates x1 and y1. The second point has coordinates x2 and y2. And what we wanted to do is we want to define some distance. We were saying that distance is the square root of, I know it's a square root, so I'll go ahead and just in here, I'll put to the 1/2 power, right? Because that is how we can most easily take a square root with what we've learned so far using the exponent operator, the double asterisk. What we're going to have actually inside is, as I mentioned before, x1 minus x2, but we wanted to square that quantity. So it is positive. We are dealing with a distance, so we want everything to be positive. And then the second thing, right, we needed to do was the same thing with the two y variables, y1 minus y2, quantity squared. I do have these parentheses here, so I will do my addition first and come to the conclusion on what's inside of these parentheses. And then when I'm all done, I'll take the square root of everything. And lastly, I just want to go ahead and return that distance. If I go ahead and run my test here, I do get a correct solution.